Welcome back, friends. In this video we'll talk about the displacement time graph and the velocity time graph. So I'm going to take a real life scenario. Let's say this is a person. This person is standing here at location A, and this is the origin point also. Let's say this is his home, and he moves a distance of, he covers a distance of, let's say 100 meters in 20 seconds, and he reaches to the destination B, and he stays here for 5 seconds, does nothing, seconds, and then he again starts moving in the forward direction. He covers, let's say 150 meters in 30 seconds and reaches to another destination. That's his final destination, C. And then what happens, he stays here for 10 seconds and then starts moving in the opposite direction, doesn't stop anywhere, and covers this displacement of 250 meters, because this is 150 and this is 100, so this displacement of 250 meters in let's say 40 seconds. Just to make my calculation easier, I'll convert it into 50 seconds, and he reaches to the original point. Now I wanted to find out I wanted to draw this whole scenario on a displacement time graph and the velocity time graph. So first of all, if I look for the displacement time graph, the displacement will be on on y-axis. This is displacement and this is time. Time is a scalar quantity, displacement is a vector quantity, so upwards we will represent the east direction, so this will be in the downward direction, so east upward and positive, and west in the downward direction. Now he started from this point. This is the origin point. When we're calculating the displacement, if you've watched my previous video, I've emphasized while calculating the displacement we emphasize a lot on the origin point. So this is the origin point, mark my words, because you will need this thing when we will talk about displacement time graph. So this is the origin point, and now you started, and let's say if I wanted to, this is here, this is 20 seconds, and then he stopped for 5 seconds somewhere here, and then 30 seconds somewhere here, and then 10 seconds, stopped here, and then covered the journey back. So this I can mark here. This is 20, this will become 25, this will become how much, this will be 25 plus 30 will become 55, and 55 plus 10 is 65, 65 plus 50 is 115 seconds. Now I wanted to show the displacement time graph. So let's say this is so he started from here and he covered 100 meters in the east direction. So the time is moving, time has started clicking on, so time is increasing in this direction. So displacement, he is moving also, so displacement is also increasing. So we will get a slant line. Both things are increasing at the same time, time and the displacement. And he covered, let's say this is the 100 meters displacement. So this is 100 meters displacement in the east direction. Then he reached here, and then he stopped there for 5 seconds. So it means he's not covering any displacement. He'll stop here, and the displacement is nothing, so they will draw a horizontal line. But the time, why horizontal line? Because time is being elapsed, and he reached to this point. And then when he reached to this point, he again moved in the forward direction. He covered 150 meters more, and so in the next 30 seconds, so 150 meters more, so he is moving in the upward direction because this is moving in the east direction. So this is, he covered 150 meters in next how much seconds, 30 seconds. Then he reached to this point and he stayed there for 10 seconds. Again means there will be a flat, you guessed it right, there will be a flat line. Yeah. And then in which direction shall I draw? Because now after that he started moving in the opposite direction. Shall I start drawing the graph here? No, he is still he is still in the east direction with respect to his origin point. He's just moving in the backward direction. He is not in the west direction with respect to the origin point. That's why I said that when we are calculating the displacement, origin point is the most important. So the graph will be drawn somewhere here when he is in the west direction from the origin point. Right now he's still in the east direction from the reference point, which is the origin point here. Now he's moving backwards, so we'll continue this graph, and then he covered this displacement and came to the 0 line. So this is the 0 point, so he will reach to this point. This is his net displacement. If I have to calculate the net displacement for this whole process, net displacement will be the point where the graph ends. The graph ends at the 0 displacement. Again, he started from home and reached home, so that also concludes that whatever we've drawn is correct. Now if he, let's say suppose that he moved somewhere in this direction, then I would have moved this graph in this direction, because now he's in the west direction from the original point. Make sense? So that was about the displacement time graph. Now I wanted to, by keeping this thing in the mind, this was the displacement time graph, I wanted to draw the velocity time graph. So let's draw the velocity time graph for this journey. So to draw, before we start drawing the velocity time graph, we need to find out the velocity also. So from A to B, he covered 100 meters in 20 seconds. And what is his average velocity? V average value will be equal to 100 minus 0 divided by 20, which comes out to be 5 meters per second. And mark my words, this is an average velocity, means the velocity remains constant in every second of his journey from A to B. Now I wanted to find the average velocity for second section. So this is section 1. For this section, second section, we can see there he hasn't covered any displacement because he stayed at B. So V average for second section, this is 1, I'm going to name it as 2. This will be equal to 0 meters per second because he hasn't covered any displacement. And for the third, when he moved from B to C, so V average from B to C will be, again, this will be this total displacement will be 250, because 100, he started from 100 and covered 150 meters in addition to that 100 meters he has already covered. So 250 minus 100 divided by the time taken is 30 seconds. So this will come out to be 250 minus 100 is 150 divided by 30, which will be 5 meters per second. And then what he did, he stayed there for 10 seconds. For section 4 here, the velocity will be 0. I'm not going to do that. I'm directly going to jump to the fifth one. So for fifth one, he will be, so it's 0 meters per second. For fifth one, it will be let's say this is 250 meters, 250 in the opposite direction. So it is, he started from 250, means that will be the initial, sorry, I got distracted by the message. So V final will be, this is 0, D final, this is D final, and this is D initial for the final one. So this will be 0 minus 250 divided by 50 seconds. So this will be in the opposite direction. So this will again come out to be 5 meters per second in the negative direction. Now I wanted to draw the velocity time graph for this one. If I draw the velocity time graph, it will be for the first section, it was 5 meters. So 5 meters, it's an average velocity. Remember we've said for first 20 seconds it was 5 meters, so it will be a straight line because it's positive, it's in east direction. And then for next 5 seconds he didn't move. For next, let's say this is for first 20 seconds, and then after that for next 5 seconds he didn't move. So this will be a plain line because his velocity is 0. So this, at this point, this will be a horizontal line, and then again his velocity moved up to average velocity changed to 20 meters per second. So this will be 20 meters per second. This is 20, and then after that for the fourth part it was 0 again, and then for the final part the velocity was -5. So in which direction I have to draw? Velocity has changed, so it will go in the downward direction. So this is the west. So this concept of velocity is different from the displacement time graph. In this, when he started moving in the opposite direction, we have to move the velocity graph in the west direction. So this is 5 meters per second, and he stopped here. So that will be the velocity time graph. This is velocity, this is time. So hopefully you were able to understand displacement time graph and velocity time graph. I'll see you in another video. I will talk about the acceleration time graph then. Bye now.